See this problem. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 newtons. What is the distance between the two spheres? What is the force on the second sphere due to the first? Our motive is there is a small charge, let it be Q1, and another big charge, let it be Q2. So there must be a force, Coulomb force, between those two charges, and the distance between these two centers is D, and the force is Fc. So we need to find out the distance between those two charges. That is one of the given question. And one more. So here Q2 is applying some force on Q1. That is the given force 0.2 newtons. And we need to find out the force experienced by Q2 due to Q1. So if you consider the force experienced by the small charge due to the big charge as F12, which is equal to 0.2 newtons, so we need to find out F21, that is the force experienced by big charge due to the small charge. That is our motive. Now come to the investigation part. Q1 small charge is equal to 0.4 microcoulomb, that is equal to 0.4 into 10 to the power of minus 6 coulomb, and Q2 is equal to minus 0.8 microcoulomb, that is equal to minus 0.8 into 10 to the power of minus 6 coulomb, and the force F12 is equal to 0.2 newtons, and the medium is air. So for air medium, the medium constant K can be considered as K is equal to 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space, or even for air also we are considering the same, and the value is 9 into 10 to the power of 9 Newton meter square per coulomb square. So we got some values. Now we need to find out our motives. Now come to the resolving part. The Coulomb force is given as K into Q1 Q2 by D square. So if you get the expression for D, it will become like square root of K into Q1 Q2 by F12, that is equal to root of K is 9 into 10 to the power of 9, and Q1 is 0.4 into 10 to the power of minus 6 coulomb, and Q2 is, here we need to consider the magnitude, 0.8 into 10 to the power of minus 6 divided by, and force 0.2. If you consider minus here, for the force also we need to consider minus, because for opposite charges, because Q1 is positive charge and Q2 is negative charge, so between two opposite charges there will be a attractive force. So every attractive force will be having negative sign before the value, before the magnitude. So that if you substitute that minus here, these two will get cancelled, so you will get the same. So we are working on the magnitudes only. Now I want to write the integral parts aside. 9 into 0.2 once 0.2 force is equal to 0.8. So here I am writing 0.4 as 4 into 10 to the power of minus 1, and 4 into 4 into 10 to the power of 9. Here another minus 1 we got, so minus 1, minus 6, and another minus 6, that is equal to, so root of 9 is 3 into 4 into 4, root is 4 into, and here 10 to the power of 9 minus 13, so we will get minus 4, and square root of 10 to the power of minus 4 is 10 to the power of minus 2, that is equal to 12 into 10 to the power of minus 2 meters, or we can write 12 centimeters. So the distance between two centers of the objects is 12 centimeters. Now come to the second part, that is what is the force on the second sphere due to the first one. So that is F21. According to Newton's third law, for every action there will be a opposite, equal and opposite reaction. So here also for F12 you will get F21 which is having same magnitude but in reverse direction. So the magnitude of F21 is 0.2 newtons only, but it will pull opposite to the F12. But its direction is opposite to F12.